Hello, so this is my 5th video in the Algebra 2 series. And this will be covering this video will be covering just some systems of equations. Oh, thank you. Let me, bro. Thank you. Okay, we'll be covering some systems of equations, and it'll be a pretty short video. But yeah, let's just get into it. So, bro, okay, hold on a sec. Excuse me. Alright. A system of equations is essentially when you have a combination of two or more equations, and then you're supposed to solve for both variables. That's all it is, pretty much. So something like this. This is what we would call a linear system of equations with two variables. So there's two variables, obviously, x and y, and it's linear because these are linear functions. And if you remember, the system to a linear system of equations is where the lines intersect. So it'll be this point, x, comma, y. So there's a couple ways that you can solve these if you remember from Algebra 1. I think the easiest one that we can pull off is substitution. So, in other words, since this is equal to y, why don't we just plug that in over here? So in other words, we can do that. Now let's solve for x. I'm just going to multiply both sides by 4. I'm going to move over here. By doing that, we get x is equal to -4. Now, we can take this guy, plug it into either one of these equations to get our y coordinate. I'm just going to go ahead and plug it into this guy. So y is equal to 4. And to write the answer, it's going to be a point. So it's going to be -4, comma 4. And that's our solution. Now, that was pretty much review from what we did in Algebra 1. Now, let's try something a little harder. Let's do something with 3 variables. And we'll make it interesting. Okay. Now, let's try this. Finds a quadratic Now you might be thinking, well, that's a little complicated. Well, it's pretty much the same thing, except now we're just gonna have 3 equations. So let's first, we have to set up the equations using this information. So when x is equal to 1, y is equal to 3. So we can say this. Just plug in 1 for x and you get 3. Now we do the same thing with the other stuff. We can say this. When we plug in 3, we get -1. So why not? If we plug in 4, we get 0. Okay. Now what do we do? Let's take it one equation at a time. We're going to do this with elimination. So we're going to take these guys, and why don't we subtract them? I'm going to subtract this equation from this guy. So, in other words, if you subtract the top equation from the bottom equation, you're going to get 8a plus 2b is equal to negative 4. All right. What do we do with that? Let's subtract this from this. Okay. 16 minus 9. Can I do that? Wow. I think it's 7. I hope so. Okay. Now we can do elimination again. So I'm just going to multiply this guy by 2. And now I'm just going to subtract bottom from top. So 8 minus 14. That should give us negative 6a. And then negative 4 minus 1. Oh, sorry. This should be 2. Because I multiplied it by 2. My bad. Negative 4 minus 2 should give us negative 6. And we get a is equal to 1. Okay. Now we can take this a and we can plug it back into this. So 8 plus 2b is equal to negative 4. Okay. In other words, 2b is equal to negative 12. B is equal to negative 6. And now I'm just going to plug both of these guys into the simplest equation where we had all 3, and then we should be good. C should be equal to 8. So now that we have all of our variables, let's write the equation, the quadratic. So a is equal to 1, x squared, b is negative 6, c is 8. We're done. And this is an application of systems of equations. And this is why they're kind of cool. But this is why we need these tools like elimination and substitution to be able to solve them. And by the way, that's kind of the method for solving systems of 3 variables. You eliminate one variable, and then you just keep going, pretty much. Eliminate one variable and 2 equations, keep going, and then find one of the variables, plug it back in to get the other one, and then use those 2 to find the next, and then, yeah. Let's complicate things a little bit more. What if we have a nonlinear system? So let's try this guy. Okay. Now, when we have a nonlinear system, we can have multiple points of intersection. So we can have multiple answers. For example, let's say we wanted to find the system equation between a circle and a line. Well, there are two places where it intersects, here and here. So there can be two answers, there can be sometimes even 3 or 4 or more. But yeah, so our job is to find every single one of them pretty much. And I'm going to do that with substitution. We can easily solve for y in the top equation, so I'm going to do that. Y is equal to negative 2x plus 4. And I'm going to substitute that into the bottom equation. It's going to get a little messy, but it's okay. I'm actually going to expand this. So we're going to get x squared plus 2x plus 1. And I'm going to simplify this guy before we get any further. So this inside is just going to become negative 2x plus 2 squared. That's what that is. And so if you expand that out, that should give you 4x squared minus 8x plus 4. Okay. Now, we gotta simplify this. So this should be 5x squared minus 6x plus 5 is equal to 4, and then we can just move that over. 5x squared minus 6x plus 1 is equal to 0. Okay, do some factoring. Two numbers that multiply to 5, or yeah, and add to negative 6. So we should be able to break this up. Minus 5x. So this, factor by grouping, pull out 5x, x minus 1, pull out negative 1 here, and then, okay. Now, obviously now our answers are x equals to 1 and x is equal to 1/5. And now all we have to do is take these and plug it into one of these equations. Quick tip, I actually prefer plugging it into the linear system because sometimes if you plug it into the other one, it'll give you a different answer or like a positive answer instead of a negative answer. Sometimes it can do that, but yeah, I'm just going to plug these s choices back into the linear equation. So plugging in 1 gives us 2. So 1 comma 2, that's one of the answers. Plugging in 1/5, let's see what that does. Gives us 18/5. These are two answers. Sorry, I'm spending a lot of time erasing. Okay. Now we're going to get a little bit more complicated. This is a solution that can have 4 answers. All right. Now, honestly, I think the easiest way to do this is by substitution. Y is equal to 4 over x. And plug that into the top equation. So if you do that, you get this. Of course, square it becomes 16 over x squared. And then times 4. So 4 times 16, that becomes 64. 64 over x squared is equal to 20. I would multiply both sides by x squared to get rid of the x squared in the denominator, so you actually get x to the fourth. X to the fourth, I'm going to move the 20 over. So minus 20x squared plus 64 equals 0. Okay. Now this looks a bit ugly to factor, but this is pretty much just a quadratic. Two numbers that multiply to 64 and add up to 20 are going to be negative 16, negative 4. So this actually factors really nicely into x squared minus 16 and x squared minus 4. And if you guys know, both of these are differences of squares, so this gets broken up quite nicely. Okay, so our 4 x coordinates are x equals plus or minus 2 and x equals plus or minus 4. Now, I would plug everything into the bottom equation, this guy. So what is that? Xy is equal to 4? Or sorry, y is equal to 4 over x. And this should give us all the answers. Plugging in positive 2, that should give us 2. Plugging in negative 2, that should give us negative 2. Plugging in 4 should give us 1. Plugging negative 4 should give us negative 1. And these are the 4 answers to our system of equation. I know it gets a little bit ugly, but all it is just using all your algebra skills pretty much and putting it together. Okay. Now on to some systems of equalities and equalities. I'm not going to go over it too much. It's pretty straightforward. So how do we graph this? X is less than 2. Well, it doesn't take a genius to figure this out. Literally, all x values that are less than 2, just shade that side. If it's asking you to graph something like that, just do that. Let's try something a little bit different, but kind of the same. X squared plus y squared greater than 1. X squared plus y squared is less than or equal to 9. Okay. This requires that you know the equation for a circle. I did not actually cover this, so essentially the equation for a circle is h and k are the center, the coordinates of the center, r is the radius. In this case, the center of both circles is 0, and the radius for the first one is 1, and the radius for the second one is 3. It's a really bad circle, but it's okay. And actually, I'm actually wrong to draw it like that. And I'm drawing it dotted because it's not an equal sign. It's not a greater than or equal to. And essentially, all you have to do to graph this inequality is just shade in between. And this is dotted because it's only a greater than sign, not a greater than or equal to. And then the second one, with the radius 3, this one you draw with a solid line. Anyway, that's kind of it for systems of equations, nonlinear systems of equations, systems with 3 variables, and some inequalities like what we just went over. Yeah, that's kind of it. It's really just applying what you already know about algebra into like intersections and stuff. And that's kind of the main idea. So I will see you in the next video.